Okay, so this is our first run on the Bantam CNC mill, desktop CNC mill, and we got the software up here. So we're just starting. This is the very first cut for our mill. And Andres and Kat have been reading through the manual, so they're going to be telling me what to do and keeping me from making mistakes. Okay. So you can see the software here. And so first thing, it says down here, machine is disconnected. So we're going to make sure that that's connected.
Unplugging it, plugging it back in now that it's on.
Yeah, maybe. Or like here.
From the computer?
Yeah.
Yeah, let me do this. I'm going to
Yeah.
pull it off. Okay. And plug it back in. Yep, there it goes, initializing. Look at you with the dice. That's great. And so, yeah, the discussion was what tool is in there. Right now we have the little probe in there. You see, you want to point at it?
Yeah, this probe.
So that's just a metal rod. It goes down and it probes the workpiece and finds out the edge of the workpiece. So that's how it sets the origin. So it knows where to make the cuts. So,
Do you already have the file downloaded, the tool holder downloaded?
not sure.
Okay, so if you go back, if you go to the software, and then
Yeah, so this would be the piece here.
So if you click on that, it'll take you to the website.
Okay.
Okay.
This one here.
Yeah, so I think, yeah. So click on that. And then scroll down a little.
Okay.
And that first file, wait, on the files tab,
Yeah, down here.
that first one. So we'll download that file,
Mm-hmm.
and that's basically what we'll insert into the software. And
Okay,
that's
very good.
how it tells you, or tells the thing what it needs to do.
Sounds great. I suppose just pull that back and we'll drop this down. It didn't look like it was interlocked. Yeah, it is interlocked. Okay, well that's good.
There we go.
Makes it safer.
What tool are you running?
We're doing the basic tool holder. So
Yeah, so this is the piece that we're making.
Yeah.
It cuts out 4 square sockets for the tools. These little
Okay.
pieces fit in there, so that it's a holder for all these tools. And then the collet wrench. There's a pair of collet wrenches, and they fit in there too.
Cool. So now if we go back to the software, I think.
Yeah, I'm looking to see on here. It still says initializing, so I'm reading through.
Yeah, I think maybe
Turn on.
one more time unplug it now that it's closed.
It says plug it in and then turn on the machine.
Oh,
So
okay,
go ahead
so
and maybe cycle it down and back up.
Okay, so I'm gonna turn it off and turn it back on.
Mm-hmm.
To the back. Okay.
Okay, it's
Shutting.
connected. Yeah.
Okay, and then turning it back on.
Spindle
Great.
rebooting, yay.
Okay.
Here we go.
Okay,
Yeah, I'm
been ready, home the machine to get started. Okay. Are we ready to home?
Yes.
Start homing. So then that takes all of
Are you
the.
recording?
Thank you for recording.
No.
Alright.
Have to get a location.
It was pretty much already at home.
Yeah, I guess so.
Yeah.
Okay, so now if we go to initial setup. So now we're going to open file
Mm-hmm.
and select the file that we want to.
Make sure we're capturing all these windows. Yeah, we're capturing them.
Okay. So we select the file that we want to
Yeah.
create essentially.
So I went ahead and put it in the downloads. Yeah.
And if you can see on the top part of the screen, it shows the estimated time that it'll
Yeah, I
take.
see. 37 minutes. Mhm.
Correct. And then on the left-hand side, those options, we have to select the tool, and the milling tool's right there. And
Okay.
so right now we have the probe, so we need to select scroll down to find the 1/4 diameter probe right
Yeah,
there.
there you go. So that's the tool that's
Yeah.
loaded.
Mhm.
Loaded stuff. Yeah, so it says initial setup, material setup, plan setup, summary, run job. It'll walk you through each step and won't let you start a job until you've filled out all the necessary information. So that's great.
So let's go to the jog menu.
Okay. There's a next button. Should I hit the next button? Yeah, so here's
Material.
yeah.
Go to, is it material setup? No.
I hit next and went to material
Mhm.
setup.
No, go back to initial setup.
Yeah.
There's supposed to be a section that says about installing. Oh, that's right there.
Install tool, yeah.
That's where it was.
Yeah, okay.
So if we click on install tool,
hit that.
and so now whenever you select the install tool, it basically moves the machine to the center,
So that
and-
you can
so you can
move it and
maneuver
change it out. Yeah.
And so we select the tool that it's on. So right now we have it set to the
This
1/4.
is where we set the quarter diameter probe. Yeah.
Yes, and then
And
next, since we've already got it installed,
Yeah.
we don't have to do anything.
Yeah, that's right. And
Um,
then here's the jog menu.
correct, and then it should just be installed from there.
Now do you have to go find the XY coordinates? on
Yeah,
your-
it'll do that automatically, but I don't know when.
No, I was wondering if it had to set on your piece of material.
Yeah, it'll do that. It's got a conductive probe, and so it'll go and it'll find the edge in
Okay.
the top. So it'll find the origin.
And so now what it's asking us to do, because I think there's like a touch off thing somewhere there. Step back. Yeah, so selecting start, what it's going to do now is it wants to drop down and touch the edge of the
Build plate.
build plate.
Okay.
And so the menu on the right basically dictates
let it
like
do
left or
Yeah,
right.
come
Okay.
just moves it.
Mm-hmm.
Okay, so hit
So
start.
it looks like it's in the right place. So
Yeah,
should
we
be
have to
okay.
make sure that the probe is going to touch the thing.
Yeah.
We're looking at it from left, right, and then
Oh, I see. Like
Yeah,
it's not
like
going to miss
mainly
the
move.
plate, or it'll
Yeah.
drive it as far down and
Yeah,
hit the inside.
correct.
Yeah. So it looks like it's going to hit the
Yeah.
plate. Yeah. See this? I want to. Yeah, we are recording this. Okay. Even though it's going to be a lot of.
cutting out. Yeah,
Yeah, touch off in progress.
so it does that really slowly.
Yeah, and then it'll zoom back up once it touches it.
And that goes really slow.
Yeah.
You don't want to crash your mill.
Yep.
Crashing your mill is such bad. I'm David.
Oh.
Cat.
Yes.
Andres.
Andres?
Yes.
Cool.
Nice to meet you, David. Like, well, thank you.
Rachel Christie.
Yeah, exactly.
Yep.
Okay. So now we'll go to the material setup, and now we're going to get it ready for.
Okay. This milling tools, though, I'm worried about this because we picked the quarter diameter probe here, and that's not going to be our milling
Yeah.
tool.
Okay. So then we will select the tool that it is, which is going to be the helical
The square and mill. It's 00150 is the.
from the helical. So it's
Yeah.
going to be
Is
helical.
it one of these up here?
It should. I think it should be this.
Yeah, the helical one.
Yeah, 1/4 to flat.
Two-
It
yeah.
says flat and mill, but
Two flute flat end mill.
Yep. Yes,
yeah,
that's the one.
It's the one. Yeah.
Okay.
'Cause it's a helical.
Yeah.
Okay. So now we go to the material setup, and we're going to now probe where the block is. So.
Okay. Material setup. Okay.
And then from there we go to material placement. So go down, scroll down to that tab where it says material placement and
Mhm.
open that up. And should be something about probing.
Yeah, material offset probing routines.
Yeah, is that a thing we can click? Or
Yeah, we can click that. Let's see. Aluminum, no, automatic stock probing.
yeah, the automatic stock probing is what we want
Yeah.
to do.
Yep.
And we follow the on-screen prompts.
Yes. Separation.
Okay, so it automatically locates the stock. Are we recording the software? Yeah, we are. Make sure your stock is making direct contact with the T-slot bed or the spoil board, and is also electrically conductive like aluminum, brass, or copper. Okay, next. Use the jog arrows on the right to move the probe about 1 inch above and 1 inch inset from the front left corner of the stock. Okay.
And I think you can change the size increment that it changes.
We're going big. 1 millimeter.
Yeah, we're a little bit a ways from.
Yeah, we are.
Can you change it to?
It says step 10 to jog.
Here we go. Okay, hold down button.
Whoa.
Okay. Need to go in about.
Makes you feel like you're working a claw machine.
That's about 1 inch in.
Yeah.
Okay.
So does it want it right on top of it or just to the
1 inch in.
Okay. So there. Little.
a little bit more? I think.
Yeah. Good. That's good.
That's like good.
Yeah,
Okay.
that's good.
And then I gotta get it about 1 inch above. I don't want to crash it.
A little bit more.
Yeah.
Right about there, I think. Is
Okay.
good.
Yeah.
That's good.
There's a delay when you stop
Yeah,
clicking
exactly.
before it stops.
Yeah. All right, that's cool. All right, and then we're ready to hit start.
Correct.
Okay, this is pretty fun. Look what it hit
Yeah.
those screws. Yeah.
Ooh.
You know those toe clamps?
Because it's gonna probe the side.
Yeah.
Oh,
Oh,
the toe clamp's gonna be in the way.
yeah.
Yep.
Was it
Probe is
stopping?
already tripped. Probe error. Yeah. So I need to jog it over some. If anything looks wrong, okay. Let me hit cancel. Okay, and so we're going to go back to this probing routine, automatic probing next, and then we'll go to jog. We need to scoot it in a little bit so it doesn't hit those. I'm going to scoot it down so it'll be easier to.
See where it's okay. More
Okay.
forward.
I'm going to go this way.
Well, I think it has to be on the other side. It has to be to the left of the stock clamp because then whenever we're adjusting it from.
Yeah, it's at the front left corner.
Mm-hmm.
You know what I'm saying?
Yeah.
But the one that probes like it moves to the left and then it starts coming to the right. Then it's
Yeah.
going to. I don't know if it's going to.
Well, what I'm going to do is I'm going to scoot it back. Okay. Let me see. I might go left a little bit, but I just want to get it on the inside of that toe clamp.
Okay.
You see what I'm saying?
Yeah.
Yeah. So that's
within that. You can go a little bit more.
a little bit more.
Just slightly, yeah.
There should be good.
More or what?
No, that looks
I
fine.
think that's fine.
Yeah, I think that's good.
Okay. And so we'll see. All right. So try this one now.
Yeah.
Hopefully it goes to the left enough to get
Enough,
on the
yeah.
inside of it.
No.
It doesn't go far enough. So it has a predetermined how far it goes.
Yeah, it does.
So we do
So
have
either
to
the toe clamp needs to be moved or
we move it to the left corner, and so it won't be an inch from the thing, essentially.
Yeah. Okay. So what we'll do here is we clear this. Can we go to the left of the toe clamp? Is that what you're saying?
Yes, go
Yeah,
on the
let's
left of the
do
toe
that.
clamp.
Okay, so back again. We'll get it close so we can see. Okay, and then let's see. Let's go this way.
Yes, it has to go to the right a little bit more. Going a little bit more. Right, a little bit more. I think right there should be good.
That good?
Yes.
Okay, and then I think we're ready to start it now. All right. Third time's a charm.
if research only took 3 times.
Yeah, really. Way over there.
It's just gonna slowly walk until
Yeah,
it
that's
finds
right.
it, and I have a bet that it's gonna lift it up and go back to where it was because it says it's gonna move 1 inch over
I don't know. We'll see.
and then come up. That's my bet. Oh, I was wrong. Clearance is clearance.
Yeah. And so it should put this blue box then on the build plate where it's supposed to be. Okay, so it knows where the material is.
Correct.
So we know how big our material is. So now it knows.
Yeah, it knows how thick it is.
Mm-hmm.
And
And
it
now-
at least knows the front left corner.
Yeah, and we told it what the length and width of the material was.
It should already be preset because
Is
we
it
haven't
up
removed
here?
it.
Mhm.
Yes.
Yeah.
Okay.
If we look at the numbers, it should be.
Doesn't quite look. Well,
It's 4.33 for the X. Is that around?
is it giving us inches or what?
Yeah.
Because in here it's millimeters.
Yes, I think these are in inches.
Okay. 25.4.
There's a way to change it to inches to see.
Yeah, there probably is. So anyway, we got 75.
Mhm.
25.4 divided 2.95 inches is the X.
It should be 4.33.
Yeah. And then the Y is 50.
Mm-hmm.
That's going to be like 2 inches.
The Y should be
3.14.
Yeah, 3.14.
Yeah, so then we don't have this. This isn't set. Oh, shoot. Convert those to millimeters.
Okay.
I'm going to send them this video to show them all the troubles that we had.
So the first one, the X should be in 109.982
Okay.
millimeters.
Yeah, we don't have any of these standard sizes. There's no 109.
Can you type it in?
Yeah, I'm sure I can, but I just wanted to see if it was one of these standard sizes.
of them.
So, do we know if let's see, was this X? I didn't check when we were in the jog menu because we got to put the correct, X, Y, and Z on there.
Yeah, it should look.
Yeah,
X is like this.
because
Yeah, X is like this.
X is the left and right. Because whenever how we were switching whenever we were probing it,
Uh-huh.
the left and right.
But I
Yeah.
couldn't remember. I was hitting it over here.
Oh, okay.
And I
Yeah.
couldn't remember if X was
And
left
Y
and right.
again up and
Forward and
yeah,
back.
forward
Yeah,
back,
Z
yeah,
is
and
up and
then
down.
Z is up and down.
Okay, so what's our width here? Do y'all know? Does it say what X and Y and
This is
Z
what,
are?
it just says what the dimensions should be.
And it says X, Y, and Z, or does it say?
Yes, X, Y,
Okay.
and Z.
Okay, so what was the X supposed to be?
So the X-
109?
Yeah, 109.982 millimeters.
Okay, 110 and 109.9. So
Yes.
110.
The Y axis should be 79.756.
So 80.
Yes, and then the Z axis should be 15.875. So 15.9.
Yeah, okay, this says 15.88, so that's
Okay.
good. Well, I mean, let me go ahead and get the real numbers. I put in 80, but it was 79.1?
It was 79.756.
Okay, and then the X was 109.
109.982.
Okay, see if I can zoom this guy out. Yeah, that looks much more correct.
So now we'll probably have to probe it again, I'm assuming.
You don't have your
Yeah.
fixturing on there. That's okay.
So I'm doing shift left mouse button to pan it back and forth.
Probably the same camera controls that are in Fusion V6.
Yeah.
Yeah.
So that's pretty cool. Okay.
Now we have to do the probing thing again.
Why do?
Yeah.
I believe so. Because I don't. Do you see how that? Well, I would just to be sure. I don't know if changing the material size would change
Okay.
the
Yeah,
location.
that's fine.
But I'd rather just be safe. And it should already be.
Okay. Yeah, so X was left and right.
Mhm.
Yeah.
Left
And it's already set to where it was, so we would
Yeah,
just
that's
use
right.
it again.
So.
Measure multiple times, crash no
Yeah,
times.
that's right. Exactly. I saw some great machining crash videos on YouTube when I was looking up some of this stuff. Oh, just makes your heart sink. Oh.
Have you looked at? You probably haven't, but that Titans of CNC, they have a whole curriculum made out for learning how to CNC mill, CNC machining. It's pretty good. So, they're good. And next time I go up to Dallas, I want to go tour their facility. But
Okay.
All right.
Now everything is prepped to go. Now we just have to change the tool again. Because now we want to put the tool that we want to cut. So if we go back to initial setup.
I'm going to hit accept on this.
Correct.
Yes.
Now we go back to initial
Initial
setup
setup.
and install a tool. Okay, so now this will center the machine, and now
Yes.
we'll have to
It's
take out the probe.
Okay, so we're going to move the video cameras.
So
Just do that. And pop it all the way up. There we go. And here's the wrenches. Pull this out here like this so we can,
do you have room?
yeah, you got it. Okay.
You want to do it?
You can do it.
I'll try.
all right,
So-
bring
That will fall off.
This one was in the top, right?
Yeah.
Okay. This one goes here. Is it like, oh no, it's right.
larger one holds the collet, and
Yeah.
the smaller one holds
So it
the
has the silver.
silver one.
Get the right angle in there.
Yeah, because it's very biggy.
There you go. Okay. And then this one goes here.
And the silver part.
Or you might have to rotate it to the other side.
Easy.
Sometimes they don't just have a spindle lock, you know, which is a little pin that goes in and.
That one.
That one was fine and I did it again.
What was that?
These angles. There, okay.
Rotate the top one like to your right until you find the spot that it
Yeah.
hooks on.
Yeah. Do you want to try?
If you want me to.
The camera's getting me messing up here. This one's fine. I'll put it in. It's just yeah. Okay.
I got it. It's fine.
I see it. Yeah, it's just got two flat spots.
Mm-hmm.
Okay.
So we have to find where. There
There you go.
So that one's
Alright.
okay. Now that I
And you
rotate
turn it
it.
around where it's easy. Then
Now this one also rotated too.
There
so
you go.
now-
And then put them
Put it
together.
to
Is
the
it
left.
together?
Bottom one to the left.
Oh yeah, that's right. There we go. Okay. We have to be careful because
Yeah.
You don't want to
Yes.
drop the tool; it makes it dull. Even though this is a probe, but
Here, take
like
this
when you're
one.
doing
Yeah.
the sharp tool.
Let me get that.
I know, right?
Jeez. Oh, the flat part's on this side. There it is.
Okay, you got it.
Okay.
Yeah, once you get it broken, you should be able to just do it by hand.
There it goes the other end.
No, it is this way, right? Why is it?
Is it binding up?
There we go. Okay. And so whenever you insert the tool, you push it all the way up, and then you take it out just a hair. So it goes all
Oh,
the way
really?
in, and then just a hair.
You touch
out.
it and then pull it a hair out.
Mhm.
Yeah. Okay. Now, can you
Yeah.
use the wrench to tighten it? Because
Yeah, I know. That's with the spindle lock. It's
Yeah.
I think it's a little easier.
You have to take it out and then
Find another one.
yeah.
Yeah.
So don't wanna-
And you don't want to over tighten it though.
I think.
it wasn't tight.
Is it good there? You
No.
tell me.
Keep going.
Got a quick change tool thing here.
Yeah.
I wonder if they make one
Is it good?
that is just the tool that
Use your
goes in.
fingers.
Just
Yeah, you should do
grabs.
it, but until it's finger tight, and then use the wrench. Otherwise, it'll wear you out.
Okay.
There you go.
Yeah.
Nudge it.
Yeah.
Keep going.
Just give it like a quarter turn. I don't know what they suggest.
Mm-hmm.
It says until it's tight, and then yeah,
I think that should be fine.
that should be good
Yeah.
enough now. Okay. Now we can close this back up.
Yep.
And
This one needs two.
Doodly.
There you go.
Yeah. There, that's nice.
Okay. Now we'll go to.
All right, so select the tool that you're using. That was the helical 01015. No, the quarter inch. The 150 quarter inch
Yeah.
tube flute.
Yes.
Hold the tool in place. Hand tighten the collar nut. Tighten it with the wrenches until snug.
Now we go to. Oh wait, yeah. Now it's got to touch the.
It's got to
top.
touch the
Yeah.
nose so it gets the correct offset.
So we need to move it.
Slightly over to the right.
Oh, really?
No, well.
Well, as long as
Actually,
it touches.
Yeah, as long as it's above
Yeah.
the plate. Ready to go?
Okay. Yeah.
Or you want me to scoot it down just to get it so we can tell?
Oh, it's fine.
Yeah.
Is that going to be good? Okay.
Yeah. It wants to do.
He wants to do it himself.
Yeah.
I can do it.
So do you know what the noise is from?
The noise.
Stepper motor has so many little coils that it can take tiny little steps, and so it's taking so many steps that it's actually starting and stopping. So it vibrates a lot
Yeah.
as it's going so many steps, and so that vibration is at different frequencies depending on how many steps it's taking. Yeah, so
Are they stepper motors or are they servo motors? Do they have an encoder on them?
I'm not sure.
Now we'll go
Good,
to the
yeah.
summary job, or this, yeah.
Okay, so then we did the material setup. We never did. I mean, we told it what the width and depth were. You know, I wish it would probe it that way too, so we get more
Yeah.
accurate, right? I mean, we were, I guess, pretty accurate, but so we did material setup. We did the probing plan setup now.
And the summary should contain all of that information as well. That last box.
Yeah.
And so from here we would review everything to make sure.
Okay.
it's
Yeah.
correct.
So we've got our width, 110 millimeters.
Yes. 79.
Height, I guess height is 79 going back, and then thickness, T is thickness, 15.88.
Mhm.
Alignment left. The offset from the front edge of the
Mhm.
build area. We don't have any fixturing in the way, like top clamps or anything. Looking at our plan, it's not going to hit any of our L brackets or our toe clamps. So like here, it's cutting out the side. And if we had a bracket over there, it would cut into it. What about the left? No, we're okay.
No.
Okay. Now what?
We should just go through everything, and we should be ready to go. So
Yeah,
the
I
whole point of
think
the summary
Okay.
tab is to
To
make sure
review.
that.
And it says tool holder, G code. That's the correct one. I don't know what mill single file means. Maybe it's just milling this one G code file versus the whole thing.
just that select.
Because like if we had different, like if we had to switch tools for another path with a different tool, then we'd have another, like we'd have to change the tool and then mill that, then we'll mill that file.
Yeah, I think it's
Yeah, so we shouldn't have. I think it's only if we're
It's just
selecting
a single file
Yeah.
job, yeah.
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 Okay. Yeah.
Um,
So I said just select it and then put okay.
Okay, here we
Yeah,
go.
we're ready to go.
All right.
Fingers crossed.
Hit this one here, mill single file,
Yes.
or mill all,
Just it's
probably the same.
Yeah, because there's only one.
Which one do you want me to hit?
Is it single file?
Select the missing mill single file. And
Okay.
Yeah.
If it says select mill
Yeah.
single file, then we'll do that. Milling will pause and prompt you to change tool when necessary.
Yeah.
Okay.
Okay, so that is.
Not as loud as I thought it would be.
louder.
I like the software it's showing.
You wouldn't be able to do it with it open.
With what?
With it open.
Oh yeah, it would tell stuff out for sure.
We all have to safety goggles.
Yeah.
You said what? GW, you said something?
The preview, it's
I like the
actively
software. See, it's showing us.
mirroring.
Yeah.
Is it running the clock down on the software? Like, is it showing that the time is going down?
Yeah, let me see.
Yeah,
It says this, yeah. And it's telling us what line of code it's in. That's cool. That's cool. We can change the spindle rate and the feed rate real time. Seems like it's going too fast. We can slow it down. Whatever. Sometimes it gets a little resonance. It starts to hop and chatter.
Yeah.
So you just change the rate a little bit.
And most of you can go to the tool manufacturer's website and look at what their recommended speeds are.
Yeah.
And it's a really good place to start.
And all the chips and stuff, that's called swarp. Yeah. It's obviously one of the things that in cleaning we have to get rid of.
So how does the cleaning process work?
You would take it out and you would, there's different ways to do it, but one of the most effective things I've seen is it's like a little canister that has a basket in it, and then some filters at the bottom, and you have a fan below that sucks air through that filter and blows it out, on the floor, and then compressed air. So you put the part in there, and you blow in it, and all the compressed air goes in instead of blowing the chips out the top. They go out and down
Yeah.
and get trapped in this canister. It's a fantastic way to air blow
Yeah.
the stuff off first.
Yeah.
And that I think is a great thing. They wanted way too much for it. And it was something that just runs on shop air. So there's really no motor or anything. It's just shop air goes in, spins the fan, and then it comes back out and goes through the probe. It's a great tool, but they were asking way too much. I was like, I'm just going to use a shop vac, and suck all of this stuff off.
So all of those powered up, is it reusable? Like or is it
All those what?
like cleaning up all of that, all the storage, is it reusable or would you have to dispose of it?
I don't know. I mean, in a large machine shop, I don't know if they sell that. I don't know.
I would imagine like
It can be melted down.
Yeah, a lot of them send it back to the material supplier, and so the material supplier, instead of having to go recycle and
But it would have to go way back to the beginning where they're melting it and making bar stock and stuff. And I don't know. I mean, to me, it makes sense because that's going to be more pure than any ore you mine out of the ground. It's dirty. It's got a lot of dust and hair and junk in it and cleaning fluid and stuff if you were using a liquid cooled steam process. So it would be really dirty metal chips and stuff. But you would think that they would be able to use it.
yeah.
If not, that's a great business because you're hauling away someone's trash. You need to turn it into something useful.
Yeah, I sure. It has potential.
It's already doing the second hole.
Yeah.
Pattern that it's cutting in. Just the edges and it goes in.
Yeah.
And then
Yeah, as it digs down, it sounds different.
Oh wow, so it even comes out.
The stuff coming out the side.
Yeah. Because there's little holes
Yeah.
in there.
Yeah, I'm gonna have to I've got a little stuff back over there.
It's moving.
Yeah, it really is. I mean, I have a mill at home in my garage, and I do aluminum, but I don't ever make the tool go this fast. And that just making me think I could be machining a lot faster than I ever was before. I was just sort of, I didn't know.
what type of mill do you have at home?
It's just a little Grizzly tool, a tiny, I call it a mini mill. It's not as small as this though. This is micro.
You ever think about doing a CNC conversion on it?
I thought about it, but it's not, it'd be like 3 times the cost of the mill itself, The mill was $500. Yeah. But it's, forget about doing a circle, right? It's like an Etch-a-Sketch.
Street lines.
Yeah, straight lines, that's it. I did get a rotary bed attachment so I can put that on there and then you can turn the crank and, you can do a circle that way.
A rotary, is that just this little circle thing? No, maybe
No, this is it looks kind of like that bottom plate,
okay.
only those grooves are circles. And then you put your work on there and you use those grooves to clamp your work down. And then there's a crank on the side that turns it. Yeah, so it turns it around the center pivot. And so like if you wanted to do a gear, right, you could see on the side, you could cut in and then you turn it and cut in and turn it and cut in.
If you want to do a whole pattern.
Yeah, yeah. And it's got just degree marks on the turn so you can go around and get so many degrees and then cut a whole pattern. Yeah. Or if you want to cut an O-ring groove, you know, you could drop the mill down and then turn that and you could cut a circular groove that you could put an O-ring in and seal the surface. Yeah. That's pretty good. It's on hole number 3.
So it's five holes, and then where it
4
grabs.
inches though. Yeah. And that'll go pretty fast. It's not very deep. I'm really impressed with the, you know, the whole apparatus. You know, that looks pretty good. It's pretty beefy.
Much better than my 3D printer.
Yeah.
So is the X travel done by a, so I'm on those 2 bars, but is there a gear or is it a belt that moves the,
You know, I'm not sure. Because on my 3D printer, it's a belt.
belt
It's a belt.
by,
Oh, really? Okay. Yeah. Yeah, I don't see the belt. Well, no, I see over there. I see a lead screw.
something about tightening a belt.
Really? There's a lead screw on the C and a lead screw on the X. And there's a lead screw on the Y. So these are all 3 screws. I don't know where the belt is.
The belt's probably the, from the motor to the spindle.
Maybe. Because I know what it says that over time, like it'll loosen up, so you have to tighten it.
That would make sense in case the thing gets jammed. You need a weak link. The belt is a weak link. Yeah.
Direct drives are problematic.
Is that the car? You guys
No, no. The big box over there is what this came in. Or the 3D printer. One or the other. I didn't get rid of the boxes yet in case something was wrong. Yeah. The cart's upstairs. Yeah, finally. Took a month and a half. Or 2 months, yeah.
Yeah, since the beginning.
Yeah.
Some assembly required.
Yeah.
So essentially, once we're done with like the anodizing process, here we can engrave it and start.
Yeah, so we can machine it,
Yeah.
and we can go through the anodizing process and dye it, and then we can bring it back here and we can engrave it, and it'll cut through the color and leave a silver engraving. It looks really nice, yeah. Or we could engrave it first and then anodize it. If you cut off the anodizing, you see a really nice silver.
Yeah, stands out.
Yeah.
Where you could wax fill the engraving in.
Sure could, yeah.
That's all work. We have a engraving
Yeah, so there's an engraving bit. Yeah.
well tools to get done with.
I don't know, they're right there. We got the cool kit.
Except we can't use the 1/8 because
You don't have one each
we
one?
don't have a 1/4. That's the right one.
I'm gonna buy the other stuff. This is what it came with.
That's a really video, you go about 164.
Which one?
We got this 160-foot flattened belt. That's a really video belt. That thing was great.
I bet it runs at full speed too. Real happy.
Yes. chip rope, chip for tooth, so like that.
This is great. I'm pretty excited.
It's fun to watch it.
Yeah.
Yeah.
Good to go? Okay.
You pause the job, like you have to change your flip string. Cut something really flip string so it wouldn't get messed with the thing. As long as you didn't move the workpiece. What's exactly is it? Will you? Is it plus or minus like 10,000 of an inch or what accuracy is
It's better than 10,000. Yeah. I don't know what it is, but it's better than 10,000. Sure. You can see the toe pat. That's very nice. Yeah. This is gonna be a great video because you can see the toe pad and you can see it simultaneously.
Hearing a noise coming from
Yeah, I wonder.
Like one going one way, one going the other way. That's only about halfway through.
What it says. Yeah. I guess this part is slow because it's a lot of travel back and forth. I'm definitely going to send Bantam this video because you can see the software and everything side by side. Yeah.
You're gonna be able to look
Yeah, exactly. When it's done, we need to all get in the little frame.
Yeah.
Right? it.
Oh.
Yeah,
Chair now.
it's just too crowded here.
Yeah.
So I'll just make that workstation a 3D workstation.
Okay.
Yeah.
Did you get that computer fixed? Or
Yeah.
checked out?
It's they just haven't activated it quite yet.
Okay. But it is compatible with.
Oh yeah, it's a new PC. I got it in maybe August or yeah, sometime in the summer. But I'm impressed with a laptop that can run this and both cameras and video.
Not glitching or anything.
Yeah, it's a beefy laptop. I got like 16 gigs. Yeah, yeah. And an extra graphics card. Like, not extra graphics, but an updated graphics. Yeah.
Only play games on the.
Because I knew that I would need all of the video stuff for that workshop.
Do you keep all of your lectures? Like from years and years? Or
3 years of lectures, yeah.
Oh, you started 3 years ago with the
So I want to go through and like cut it into clips. Like just small clips on topics rather than 45-minute lecture, an hour lecture. Just, 5 minutes on the wave functions or 5 minutes on, this particular topic.
Yeah.
But I have too much time.
Because you get viewers from all over the place. Sometimes they just want
Like 1,500 from India. Like, that's like my second most popular country is India. Yeah.
He's a guest professor in India.
Essentially, yeah.
Like,
Without having to travel.
They probably play you on the screen.
so by Dr. Williams, that is funny if you went to a big college and presented by Dr. Williams.
You go there.
So we're going to need credit. We're not stealing.
No, I have people call and want my PowerPoints. Yeah, they want me to give them all of my PowerPoints. You can make your own. You can get them from the video and just make your own, and that way they're yours.
You create all your PowerPoints?
What?
You create all your PowerPoints?
Yeah, but I use a lot of graphics from the publishers, like from the book publishers. I'm trying to move more towards my own graphics, like using ones that the publisher didn't produce.
Yeah.
Videos because they have
What's the next project? What's the next thing you got to go?
I don't know. I'll probably mill some of those keychain pieces because I'm going to anodize those. So we're going to make them several parts and then anodize. And so the keychains will probably be wired when I make.
It's a good test project.
You can make batarangs.
You make what?
Batarangs? From Batman?
I had the same reaction. I didn't know what that was. Thank you. You know, maybe know your mind. I mean, now that I can know that. You didn't tell me.
Especially since this is now the Batman mirror.
Batarang.
Oh, yeah.
Someone have like a bunch of different ones.
Yeah.
Batarangs. Boomerang.
Yeah. You can anodize them and dye them black, and you can mask it too. So you mask it, and then you dye it black, and then you take the mask off and put it in, say, a yellow dye, and you have a yellow vat on the black part. Yeah.
That's what I just had to just have on a desk. I made this.
That's right. Yeah.
Are you guys doing your own anodizing?
Yeah.
If you do that during the summer, I want to come in and do one.
Yeah. And then I want to look at electroplating too. So we take apart and we can nickel plate it. And so it'll be a real nice shiny hard surface. Yeah. This is 3, and then they can add a 4th axis. So we take this build plate off and put on a 4th axis machine. It's for rotary things, like chess pieces or whatever. You stick a bar stock in there, a round bar stock, and then you can rotate it in the yeah. So like if you think of on the chess piece, like the knight, the horse, you know, there's no way to make this mainly because of the overhang of the head, right?
Yeah.
So you can machine the top, but you couldn't machine underneath.
Okay.
Now, to do it on this machine, you would have to then take it, machine the top and everything, and then rotate it sideways. And you have to make what they call crush jaws. So you make special jaws that would grip that piece, that irregular shape. So you machine the profile out of 2 pieces of aluminum and make jaws that will hold on to that piece. Okay. And so then you hold on to that piece and then you can machine the overhang. Yeah. But if you have a rotary thing, then you can mount the base, and you can machine the whole horse.
Oh, okay.
Because you can turn it, you can machine. Can you imagine writing the software for that? Yeah.
It's so much to think about.
And there's no one solution for that. I mean, there's, you know, what path you choose and how you rotate and everything. There's maybe an optimal solution, but how would you even know how to write? You know, because the computer generates the toolpaths.
Yeah.
So you have to write software for the computer to figure out how to make this piece. Yeah. I don't know how to do that.
So does it cut it like perfectly?
That's what he was asking, like, what's the tolerance?
Okay,
you know, like if this wrench is supposed to be fitting in there, you know, you don't want it to be exact. But, you know, if this thing is sloppy, it may be too small and the wrench won't fit. So what's the accuracy? And I know it's less than 0.01 inches, but I don't know what it is. Maybe like 0.005, so 5,000ths of an inch. It's in the specs. I can't remember what it is. Oh wow,
It's just retouching.
About 75% done. That's where the tool is put down. Maybe these things go on top. I don't know. It's like the tool goes in and then these drop on top. Because it's just barely moving, so it's a little bit bigger than a 1/4 inch hole. So the 1/4 inch hole is Just a little facing cut, yeah. Really slow movements, yeah. If you notice the tool path, it would cut and pull away and cut and
Yeah.
pull away. And so it's going to leave a ripple potentially. And so now it's just coming along and facing a real shallow cut. And then if we had the chamfers, you know, the little curved cuts on all of the edges and corners, then we'd have to change the bit. They have like a V bit, they have a ball end mill where they can come and do those radiuses. So they can with that ball mill, they can cut those curved surfaces.
Yeah.
They'll do a stripe on the corner and then they'll move up just a little bit and move in and do another stripe. And they'll just curve that edge off so there's no sharp corners. And just feels nice when you have that chamfer on there. Yeah. And if I had the shop back attachment, it would be sucking all of that up as it cut.
I don't know how much louder it was. I don't even get that much louder.
Yeah, I don't think it'd be that much louder. I'm gonna step out in the hallway and see how loud it is. It's not very loud at all. It doesn't say the like time remaining. It just says
I wonder if we could just display the actual G code, what line G codes are.
yeah, I wonder. We're on line 17,000. So this G code used to be loaded onto the machine, like they had a little microprocessor and we were loaded onto the machine. And in my last place of employment, they were such old machines they still used paper. So they had this reel of paper, and the ones and zeros were just poked holes in the paper. And so you would feed this paper tape on there and set it on the reel and load the program. And it was a reel to reel, but it was paper. Yeah, paper tapes. Yeah.
Is someone out like I thought they'd have much more up-to-date machinery than that.
Not some of the old stuff. Yeah, yeah.
So that's what you're there to use, like to watch it and
Yeah, to feed it on, so they feed the program on, and yeah, and so then they would, get that software loaded, and they would set the piece, and then they would go into the remote bunker and they'd go, and it would machine it remotely, so it would run that program. Yay! All right, that's fantastic.
What does it say to do? Milling job complete. Would you like to run the cleanup wizard to walk through cleaning your machine? Yeah, why not? Okay. And have your vacuum ready and hit start to move the motors to the origin position. Well, I don't have my vacuum ready. So I'll go ahead and cancel. Cancel. Well, let me see if I've got the vacuum.
So you guys seniors this year, or?
No, we're
No,
juniors.
the
Well,
junior. I'm a sophomore
Good job.
technically. I have 2 more years left.
I have 1
It's my,
year left.
it's my little baby shop bag. Yeah, I just found a plug over there somewhere. It's nice long cable.
That is good.
Yeah.
They usually are like, no, we're going to find extension
Like
cord.
this. Yeah, I'll give you a little. All right.
Yeah, sucks. Good.
position, vacuum position debris carefully from the front half of the machine. Okay. We'll go ahead and get all this stuff right.
It'll do steel and aluminum and plastic.
Let me pull this stuff back. Okay.
Nice.
I know, right?
It is. Minutes apart, 45 minutes of cleaning.
Yeah. I made a special tool in my shop vac at home that would fit in these screws, and I 3D printed it. So
I think you can hit print on that.
yeah,
again.
exactly.
I was gonna take a little shorter nozzle would work too.
Yeah, I might get a 90-degree back here.
I have an exam in my class.
Okay, take care.
Answer all the questions. Answer all the questions.
See ya. That's pretty good. I don't see much debris up here. Okay, you get that off?
There you go. That's fantastic. That's a good looking piece.
It's a good looking piece, yeah.
Yeah.
How sharp are the? Do you guys still?
Yeah, they're still pretty
Pretty
sharp. Yeah. It's nice.